Hello and welcome to a new edition of GeoJournal. Today we're going to talk about a presentation I saw on YouTube. It's from Joseph Tang. The title was Geochemistry Mineral Exploration and is a very good, very basic to the point of the techniques available to us geochemists and how they can work for us in the field. The talk online, he started doing a little background and the criteria for a successful and cost-effective geochemical exploration. And at the end, he does a summary of the presentation. And we will go through all of the important slides, and I will make comments and reference to clarify or to increase the quality of the presentation itself. This slide just shows that, well, basic concept that all the good and easy to find deposits have been already found. Right now, we need techniques like geochemistry, geophysics, geology, etc., to continue the process of finding the new ores that we need. And he makes a perfect point when he says that the success of the exploration depends on good geoscientific knowledge. It's not enough just to crunch numbers or just to take samples and thinking the more samples, the better. We really need to start by understanding the genesis of our deposit in order to define which method will be better to apply in this area in order to get better results. He also talks about this concept of the evolution of geochemistry. At the beginning, we were always interested in getting the absolute amount of information. And by that, they were using more and stronger chemicals in order to dissolve the mineral grains. And it goes from nothing, just water, to the hydrofluoric acid or the four acid combination that really destroys every single grain of mineral, and then you can get the full information of the composition of the sample. But and this is very important, not all the gold, for example, to put an example, can be extracted at an industrial level. So it is not important really for us practical geologists to extract all the gold that is in the sample. Actually, we really need to extract only the gold that can be extracted later on by the known industrial method. That is why right now weak techniques like enzyme leach, MMI, even ion exchange or pure water are more useful for us as exploration geologists because it gives us the exact concentration of the gold or the copper or the lead that we can actually extract, not the gold that is in there. For us, economic geology, this is a big difference. Also, I want to mention you see this link here at the bottom right, that if you click there, you will get to the section of the PowerPoint of Mr. Joseph Tang, where he is talking about this specific subject. Then he has this graphic. This is a very good, simple graphic when he divide the possible signals that we can get. And there are basically two big fields when there is an outcrop or a channel to an outcrop, like a fault, and when the mineralization is completely covered. And for each of these situations, we have different techniques. For example, if the ore is an outcrop, well, sometimes even lithogeochemistry will help perfectly well, or the presence of a gosan. But if the mineralization is not reachable from the surface, then we really need techniques like MMI or enzyme leach that can go deep and find these weak signals of the ore body that is contained underground. When the ore body is covered, the situation is more or less the same, but we could use, for example, biochemistry or hydrogeochemistry in order to get a signal from deep below covered terrains. Again, techniques like enzyme leach are excellent for cases where the ore body is covered and doesn't have even a clear signal to the surface. So this is a very interesting summary, very well done. Then he talks about the geochemistry tool, and he's mentioning this report. You can find it online, of course. This is all public information, and it's a very nice reading. So I suggest you have time to read it. And next, he is using some public examples of the Queensland in Australia, Northwest Australia, where he's explaining how even the existing information can be used as an orientation of the potential exploration value of these maps and information. Also, this one is a very, very good table. It's a periodic table that is divided by colors, and for us, the blue colors, the ore related minerals, are the most important one. And this is one of the reasons why multi element analysis is so important. You do not look for gold just with gold. You need to use all the elements. The more, the merrier. Also, he mentions the use of trace and rare earth chemistry that allows you to get an idea of the genesis of the rock, the magmatic processes. I have a book, I will put a site somewhere here about how can you use the rare earth element in order to determine the most probable magmatic event that formed your ore body. He also mentioned, of course, the use of isotopic data, and I must say that 10 years ago, this was just for the academy, and not only for the academy, for the rich academy. But right now, the cost of isotopic analysis going down. Still, it's not something that the industry can use massively, but we are getting there, so keep an eye on isotopic data too. And then he mentions, in the specific case of Australia, all these sources of information that you can use that and they are for free. And this is not only in Australia. Here in Canada, for example, you go to the Geological Fund and you will get hundreds of open source data, absolutely for free. You can even download it directly through the internet. Other countries like Mexico have, in my opinion, one of the best geological surveys of the world. They have for each province all this massive information of geochemistry, geophysics, satellite information, limit analysis, geology, everything for peanuts. This is the kind of information that you need to have before you even go into the field. And then he mentions, and this is really, really a good point. I like this part when he was talking, saying that even the data that we now will consider, oh, that data is obsolete. They use different labs. They have gaps. The detection limit that they used at the time was too high. And all this negative, this is just opportunity. These are the things that we can re explore in order to find new targets, even in places that have been covered previously, but not at the level that we can do it right now. So use this data for pre-planning and orientation studies, and then you can go and do some more detailed data. You can even do some kind of a regression analysis between old data and your new data and convert that data set to something more useful. This is really, really very good. Then he talks about the importance of adopting new technologies, different analytical methods. I mentioned already the partial leaching and extraction method like enzyme leach, MMI. Biochemistry is and geobotanics, both of them are very useful tools that you can use, especially in large areas or difficult access area. Here in Canada, for example, there are some biochemical sampling that they are done using helicopters flying on top of the trees and just cutting the top. And that way they cover hundreds of kilometers in one day. Then there are other specific techniques like the PXRF, the scanner, the mineralizer, etc., that allows you to get information right in the field. But I also want to mention it's not a new technique, it's a new way of collecting the sample, which I call practicing safe geology in the field. And for that, let us go to YouTube and I'm going to show you this website.
Usually, more than 90% of that material is just waste. I mean, it doesn't contain any information. So any technique that we can use to concentrate the heavy minerals, which are usually the ones that carry the mineralization, will help us get better results. We are enriching the sample on purpose, which is what we need to get good results from the lab. So normally people do the panning. And for the pan, by the way, I didn't explain the first time. If you're going to do panning normally, instead of the little cup, you have a bucket of 10 liters. And the rest is the same. So, but it is important to always have the same weight. Sorry, the same volume. Okay? So 10 liters, you're doing a normal pan, something like this, that you later find out how many cubic centimeters are here. So, and you need a balance. So you fill the material, you weight it, you got volume by weight, gives you the density of the rock. And even that may tell you immediately if there is something good or not, because the more dense the sample, the most important it is. Actually, there is another thing that I forgot to explain, so it's good that the camera turned on. Okay, where do you get the sample in the river? This is a mechanical anomaly, so you need to apply a little bit of physics. You need to sample in places where the water in the stream accelerates, but not too much, accelerates enough to wash the light fraction, or stops enough so the heavy fraction will fall. So good places, an obstruction in the river, like a falling tree, that is usually one of the best places. You pick it up before the water. I mean, the trunk is here, the water goes here, you get it from here. Okay, so that is one of the best. The second thing to know is that the river always do meanders, and from one side he erodes. There, for example, it's eroding there, and then it deposits on the opposite side. So you take the sample from here. This is a good sample. Within the area, try to find out where you see rocks like this. Okay. And I know this is a problem because all these rocks need to be thrown away, but here, in this piece here, is your best concentrate of heavy minerals in the whole size here. So you see, there, wherever you see rocks, that is where you're going to take the sample. You see over here, there is nothing. Okay, so those are the important things. So, okay, let's go back. So as I mentioned, this you do it in the field, but because we have this sample taken before, we will fill this up. You hit it like that, so it will hit it. So that is your sample. So the next thing, you weigh this, and you know how much it weighs. Then you usually take something a little bit bigger, longer at least. This is 2 square. So you take a sieve of number 4, which is about ½ inch. Okay, so you can throw away all the big rocks. So there is the sieve. okay, the visible sphere. And then we need to make sure that we're going to take a couple of spoons, that this sample is representative of the meter you sample in the wall. So we need to homogenize this extremely well and then do quarters. So this I really discovered like a couple of months ago. A very easy way to do the homogenization is just grab this thing and then you put it up. You need to put it up. You need to put it up. No, sorry. Do that. You need to do that so it will move. Okay. Okay. Now we do the same, but from this side. Be hard. It must rotate. It cannot slide. It needs to rotate. Okay. So you need to do like this. No, it's a brisk movement. Like that, okay? Brisk movement. Brisk movement. Ah, you got it. You got it. Okay, perfect. So now that it's well homogenized, we just distribute it. Make a quarter. By the way, I'm doing something really bad. Contamination. Okay. And you just throw away 2 parts. And this is your sample. Okay, so we're going to take the sample from here. So, for that, we take a condom. Actually, this is the box. Power play. This is the one that you're going to need. Because all the other one has some forms, strange forms, and smells and stuff like that. We don't need that. So you just fill the condom with water from the river. Come on. And as I said before, the best one if it doesn't have any oil on it. But if not, we work with what we have. So now that we have the condom with about half the weight water, we just add the spoons of material. I will let you do completely the full one from the side for yourself. Now remember, the tip, grab the tip.
I can't use this spoon anymore, I must pack it.
You can put more. Actually, it's amazing. It takes enough material. So, if you see, there is no sorting there. They are just like they fall. So, we grab the condom here, and when I'm gonna do this first movement, and then I'm gonna lift the tip, and we're gonna do a vertical movement. Practice safe geology. So 10 seconds, 15 seconds, really, you don't need too much. And when you finish, you will see that all the heavy fraction have concentrated right here. And all this is like material, clay, etc. So basically by 50% minimum, you have concentrated the sample with the thing that you need. Now, to get the sample, you just grab it from where you want to get. Sometimes you are interested in the really, really heavy ones, you just grab the little pit. Okay? If not, but at this exploration now, grab all the whole thing, throw it away, and that is yours. Finish.
So returning to Joseph Tang presentation. He also mentioned the potential use of geochemistry. He mentions the possibility of using industrial wells, farmers, etc., just to get information at a regional scale. And he makes a lot of effort mentioning that there is a lot of information accumulated by universities, national programs, etc., that you can use for your pre exploration. You don't need to invent the bicycle, you just need to find the best one. And with that, we are finished this PowerPoint presentation of Joseph Tang. I like it very much. It was very to the point, some basic truth, but it's good to remember those basic truths from time to time. If you have any questions, any comments, leave it down there. And I will also put the link to the full presentation by Joseph Tang. And I also did a PDF document of the main images from the presentation with links to the actual presentation of Mr. Tang. With that, we finish for today, and I hope to see you in the next Geo Journal. Have a great day.